Let's continue our discussion. Um, and I want to throw a couple of interesting concepts at you right at this time. First thing is, here's an interesting question. If you remember CAP theorem, we talked about consistency, availability, and partition tolerance. What we are looking at is availability is achieved by. We're looking at the answer to this question. Now you might say that, okay, that's a fairly innocuous question, right? What's so strange about it? What's so, interesting about that? Let's assume replication factor 3 and let's insert with a partition key equals A. Now, if you remember CAP theorem, A here indicates system availability. A does not indicate data availability. That's the first distinction I want to bring on the table now. Availability has two definitions: system availability and data availability. Okay? Now the question is, why should we treat them differently? Think about it. You have 1,000 nodes. Forget about 1,000. You have 20 nodes. Your replication factor is 3. When you are inserting data based on a partition key, your data is getting saved in 3 nodes. If those 3 nodes are up and running, is your partition key not available? Of course it is available. Do I care about the remaining 17 nodes? I don't. But if there was another partition key which happens to be on any other node which happens to be down, is the system available? Absolutely. But is the data available? Absolutely not. And that is where we need to really understand the distinction, that in the context of Cassandra, we just can't use the word availability just by itself. We have to qualify availability. What kind of availability are we talking about? So when somebody says, remember CAP theorem, implicitly the availability here is system availability. System availability in Cassandra is achieved by masterless architecture. On the other hand, data availability is achieved by replication. If you store data only in a single copy, and if that node goes down, you do not have data availability. Your system might be available. Here's a little example of how we can insert data. This is Java syntax, and it's just to kind of give an idea in terms of how to work with Cassandra from an application tier. So you can see insert into, whatever. In this case, all events, some columns, and you can have the standard question mark where you bind and then you insert. Syntactically, it's no big deal, right? But the objective of this slide is to bring out a massive difference between system availability and data availability. I want to continue the conversation. When we were looking at Cassandra and the application, we've always used the word the application interacts with Cassandra. But Cassandra is a group of nodes. Application can contact any node for any operation. So somebody somewhere has to step in and essentially say, hey, wait a minute, let me take the responsibility of making sure that the application has the ability to talk to me, and I will go out there and coordinate the whole process of data insert and data fetch. In other words, the whole notion of partitioning and figuring out where the replicas are and reaching out to those nodes and all of those things. So here's the definition. A coordinator node is a regular Cassandra node that intercepts all the incoming reads and writes. For example, the client 1 can talk to node 1 and say, hey node, can you give me this particular data, and here's the partition key. Node N1 says sure thing, and it goes out there and reaches to whoever possible right, and grabs you the data. So the coordinator handles all the incoming requests. And one of the most important thing it does is the hashing. So the moment you do a select from a particular table name where you give the partition key, the coordinator is going to do the hashing. And based on the range of tokens, it figures out, okay, these are the nodes which contain the data. And then it goes out there and says, okay, if it's a select, grabs the data. And if it's an insert, it goes out there and pushes the data. The other important aspect that we need to keep in mind is whenever we are giving data to Cassandra, Cassandra will use the timestamp of the coordinator and attach it to the record. And why is this important? Consider a situation where you are looking at inserting exactly the same record from two different nodes. Exactly the same record. How are you going to identify which one is the latest? How are we going to distinguish which one is the record that we need to keep and the other one we want to discard? Essentially, I'm talking about the process of upsert. Cassandra uses timestamp to figure out what is the latest data that it wants to retain versus not. Now, if you remember, Cassandra can be a global cluster. I can have nodes in the same cluster which is spanning across multiple continents. Forget about even countries. Naturally, there will be timestamp differences, time differences. How do we address that? Network time protocol. If you do not enable network time protocol in Cassandra, it is not going to function. Period, full stop. There are no two ways about that. Now you might wonder, okay, looks like in this particular picture, N1 is getting the data and it's going to N2, M3 and N4. What happens if one of the nodes is down? We're going to talk about hinted handoff a bit later, not right now. So please keep this in mind that when we are talking about interacting with Cassandra, when we are talking about the application talking to Cassandra for inserting data and fetching data, any CRUD operation, we are essentially looking at the node that the application connects with. That node for that operation will become the coordinator. And if I want to extrapolate this, it's very simple to visualize. If the next, let's say for example, this one was an insert, next one was a delete. And if I want to do round robin, the application can choose N2 and say that, hey, N2, this is, here's a delete, go for it. So N2 will become the coordinator for the delete. The third, if it's a select, you can ask M3 to get you the data. So M3 for the select will become the coordinator. So that round robin algorithm essentially helps you choose which node wants to be the coordinator. And the good part about all of this is, from an application programmer perspective, we don't have to worry about it. When the driver initializes, it gets the entire set of IP addresses of the cluster. So the driver is already familiar with all the IP addresses. We don't have to do anything. All we have to do is what algorithm we wish to implement. And the driver will automatically write round robin among all of them, and the node that it connects to becomes the coordinator. Please note, a coordinator is not a special node. We do not require any kind of special setup, no configuration. It's just a regular Cassandra node that you are connecting with for inserting data or getting data.